Welcome to the Cosmic Savannah with Francois Campher
and Dr. Daniel Kahnemer. Each episode, we'll be giving you a behind-the-scenes look at world-class astronomy and astrophysics happening under African skies.
Let us introduce you to the people involved, the technology we use, the exciting work we do, and the fascinating discoveries we make.
Sit back and relax as we take you on a safari through the skies. So welcome to today's episode. As you've probably noticed already, it's just Francois and I in the studio. The ladies are both away at the moment.
Siamiso is in Germany and Jacinta is in Australia. So we are spread thin this year.
So unfortunately you get just our voices today. And we'll actually be introducing Dr. Nick Erasmus just now, who we've spoken to a couple of times on the podcast before. So he'll be a third male voice.
Yeah. No variety this week.
Nick will be chatting to us shortly, and we're going to be getting into a conversation about artificial intelligence, machine learning, and some of the exciting things that he's involved in.
Yeah, so mainly we're looking at how AIs and machine learning and stuff kind of interfaces with science and astronomy in general specifically. So we're having a look primarily at the Atlas Virtual Research Assistant, which is a new machine learning model that they're using to help them to filter out bogus detections in their telescope time.
So the Atlas telescope is something we've discussed a couple of times on the podcast. It stands for the Asteroid Terrestrial Impact Last Alert System, which is a very exciting name. But detecting asteroids which might hit the Earth within the space of 2 weeks, I think, was the original funding proposal, which seems to have worked, because the network has grown to stations around the world, and these days they have full sky coverage. So they're looking at the sky every night, seeing if anything's moving, or if there's any new asteroids or things to discover. But obviously that's a huge amount of data, and a very hard thing for a human to sift through. And I think that's where this idea of a virtual research assistant came from. And yeah.
I mean, we're mainly using it as a springboard to unashamedly just talk about AI in general, because we have not touched on it that much in this podcast, and it's a growing theme in astronomy now, especially with younger researchers. Myself, my theses have all been on machine learning techniques and how they work in astronomy, and several new students are coming in. They're all wanting to do either AI or machine learning applications to astronomical problems, and that seems to be a growing field of research in astronomy.
Yeah, I think not just in astronomy, but definitely, these global trends will filter into astronomy, and it's a very, very exciting time, because I think we can deal with the immense amount of data that we get as astronomers a little bit better. So we're very lucky to have Nick joining us today. He works on Atlas and has for some time, but he's also involved in the South African Astronomical Observatory's Intelligent Observatory, and he's been very involved in automating our Lesedi telescope, which is a fully robotic telescope we have at the observatory. And what that means is that it operates entirely independently of human involvement. So, it will get given a target, either by a human submitting a proposal for what they want observed, or these days by another telescope who saw something interesting and then asks Lesedi to follow up on it and take an observation. So Nick has been involved in quite a few projects at different levels, and I think we'll enjoy our conversation with him.
I agree. Let's get to it.
So today we have with us Dr. Nick Erasmus from the South African Astronomical Observatory, where I am. And Nick, welcome back.
Yeah, thanks, Daniel. It's been a while. I've actually been in your so-called studio. The first interview was in your office still, yeah.
So today in particular, we are sort of again talking about Atlas, which is hilarious because that's what we talk to you about every single time you're here. But at least this time it's about the Atlas Virtual Research Assistant. So recently there was this paper published and we noticed you were on it and we thought, wow, why not talk to you about it. So can you just quickly talk us through what is the Atlas Virtual Research Assistant?
Yeah, so Atlas, like you said, is sort of the gift that keeps on giving. So your listeners might know, or obviously knows this, that Atlas was originally designed to discover asteroids. But because it scans the entire night sky every night, it discovers many, many transients. And so there's a whole group that don't even look at anything involving asteroids. They just look at the transients, the static transients that are coming from the Atlas stream. And so that group is started at the Queen's University in Belfast, under the group of Stephen Smart, but he's now moved to Oxford. And so they're carrying on with that work. And one of the researchers in this group, Heloise, she's developed this, like you said, virtual research assistant. And so in the same way that all the asteroid discoveries are eventually sort of vetted by a human being. So there is a lot of algorithms picking up the asteroids in the frames, but eventually there's still someone sort of eyeballing these discoveries before submitting it. And in the same way with the transients, they do the same thing, but they're way, way more. And so they developed this virtual research assistant just to sort of filter out most of the junk so that the eyeballer just has to look at a couple before he sort of submits the transients. And so, yeah, that's what the VRA does. And this uses a lot of machine learning in the background to filter out all the junk. So to reduce the load of the eyeballers, essentially.
So you are still eyeballing things then, though, right?
Yes. So at least for asteroids, you really do not want to be submitting, stuff before actually someone's looking at it, because if you accidentally submit the wrong static transient, that's just sort of going to waste people's time following up on it. But if you submit an asteroid that's not real, but it sort of appears that it's going to hit us, that might cause some panic, right? So in all the asteroid surveys, it's still sort of human vetting. And in the transient as well, it's sort of your reputation at stake, right? People just don't trust it enough that they just want to submit stuff without an actual person putting its eye on it. But, that might change.
It's interesting because I noted that in the paper specifically, the team specifically didn't use a deep neural network to train this system with, which is infamous for having the black box nature. In other words, we don't understand why the algorithm makes the decisions it does, or at least it's very complicated to figure out why. And very often, these deep neural networks can pick up on things that we don't necessarily think are what they're picking up on. So there are several examples, but I think one of the more scary ones was this. Everyone was hyped about these AIs that could detect TB or cancer in people's lung scans. And it turns out the AIs that they are training, or these machine learning models, only picked up the systematics in the scanners, so it preferentially diagnosed TB for older scanners, which makes sense because countries that have older detectors technically have higher cases of TB. And so in this case, this team specifically avoided deep learning networks. And is this because the interpretability of why it makes these detections is so important in science, or is it simply because of the limited sample set that you had when you started?
Yeah, so as you say, you have to obviously always be careful of these things. And as researchers, we also want to be part of the process, right? So we also want to understand what's going on. And so the main point of this VRA is not to completely remove the human being from the process. It's just to reduce the load, right? And so you can imagine, Atlas has a field of view of 5 degrees by 5 degrees. It's literally millions of stars if they're sort of on the galactic. And so the false positives in the images are insane because they use difference imaging, right? So what they do is they take an image and they have a reference image that they subtract. And if that subtraction process is not absolutely perfect, you can detect all kinds of sort of false positive transients. And so the idea is just to reduce the load on someone who actually has to do the eyeballing. The slight caveat is that I'm on this paper because I'm actually involved in the follow-up of these transients. So I was not so much involved in the machine learning stuff. So yeah, I can't comment too much on that. And so just a little bit about that. So how we got involved is that we have the Intelligent Observatory, and one of the things is that we have robotic telescopes. And so we want to try and do completely automated follow-up of these transients that have been detected. And so that's how we are using the VRA. In that sense, there's no human being involved, because submitting the transients to the community, that you want to really make sure is the right thing. But what we've used the VRA for is, as soon as the VRA picks up something that's very highly likely to be a new transient, we automatically submit a follow-up observation to our telescope without a human being vetting that. And so that's fine, right? So if we accidentally chase after something that's not real, we've wasted a little bit of telescope time. But, the payoff is, if it's something exciting, we get on it as soon as possible. That's sort of the idea there.
What sort of results are you seeing so far? I mean, in terms of, well, a couple of things. Firstly, like the efficiency, like reducing the load on the astronomers. So what sort of efficiency is this VRA giving? And then what's your hit rate on the follow-ups?
Yeah, so that's also an interesting thing. We did realize after a while it doesn't really make sense for us to follow up on these things immediately, especially not with our 1 meter telescope. Sometimes you want to do immediate follow-up, but what we realized with our telescope, it's actually better in just waiting a little bit. And so we use the VRA in a slightly different way. We don't just look at the initial detection, but we look at the behavior. And so something might be discovered, and then this VRA is monitoring the light curve. And depending on what's happening with this light curve, it's doing something strange or interesting. Only then do we trigger. And that might actually be a couple of days or even weeks after the initial discovery. And so that's sort of where the efficiency has come up, because often, a transient's discovered, people jump on it immediately, say, it's not very interesting, and then people sort of forget about it. Yeah. And so in this case, a lot of these things, they evolve over time, and maybe a couple of weeks later, something interesting happens, and then only we follow up on. So we haven't followed up on that many things, and not that many immediate things, but the few that we followed up actually have turned out to be quite interesting objects.
So the VRA is like keeping these things in the back of its mind.
Exactly.
And checking in on them occasionally. So you're just using the Atlas data for that, because it's obviously good. What's the cadence of Atlas?
Atlas basically covers the entire night sky now, every night, because they've got north and south, and they've now a 5th unit, which we haven't talked about yet. There's a new unit in Canary Islands. Yeah, so earlier this year, this is a slightly different design to the other Atlas telescopes. It's also sort of, I guess, more Atlas affiliated, because it was not funded by NASA. It was funded by if I'm not mistaken, the Spanish astronomical, funding agency. I can't remember the exact name now. And so there was a researcher in the Canary Islands, Javier, and he thought this atlas was a really cool idea, and he's into asteroid research. So he applied for money at his Spanish funding agency, got money to build an Atlas unit, and so he's basically just built this unit, and he's piping the data to the Atlas team, and they're putting it through their algorithms to detect new things. And so there's now a 5th unit. So your question is the cadence. I think sort of almost every night or every second night they cover the entire night sky. They take 4 data points per night. So much, much higher cadence than for what, for instance, LSST is. Obviously not at that great a depth, but yeah.
Now, the VRA, like you say, it's more, you continuously still obviously check it, right, as the human follow-up part. So I suppose in that way, it showcases the requirement for still the human expert to step in, because these, like you say, very often you need to monitor how the brightness changes a little bit longer to make sure that the detection is real, or that it is interesting enough to follow up with something like Lesedi, right? The 1 meter automated telescope here. And I suppose the point is therefore that I guess it's in the name, right? It's a virtual research assistant. It's supposed to help reduce the workload on the astronomer rather than that. But I'm interested in the fact that you said that you're automatically following up with a robotic telescope. In that kind of world, what is the role of the astronomer?
Well, I mean, we only automatically follow up on the observations, but it's still the role of the astronomer to look at that data that's been collected. I guess eventually you can imagine that some AI can analyze that data, but the question is also, do we want to do that, right? Because, astronomers, we still want to be sort of part of the process in some sense.
Maybe we can talk about that, because let's look a little bit into the future. So you mentioned already the Intelligent Observatory project, which is running here at the observatory, and one of the one of the wings of that, one of the projects of that is the telemetry project, which is automating telescopes, following up on things and making sure everything's, intelligently monitored and the telescopes are talking nicely together. But the next step, once that's solved, right? Because it'll obviously always need work, but it's going to get pretty much solved at some point. Surely the next step is the data then.
Yeah. We're getting into philosophical territory here now, because I think that was our vision when we started the Intelligent Observatory we would have this AI that basically does everything and also analyzes the data, maybe even writes the papers, and the astronomer just sort of, ticks it off.
Put their name on it.
Yeah, but I think, first of all, that is a bit more challenging than people think. And second of all, we've, I think, now diverged into a more pragmatic approach to using AI, like you mentioned, the telemetry. So we're actually using AI and machine learning now more in daily operations, because that is the schlep, right? That's the stuff that astronomers don't like, maintaining the telescopes, making sure everything is working and monitoring that. So I think, in my opinion, that is a good way to be going, reduce that type of load so that the astronomers can focus on the fun part of astronomy, and that's the research. But like you said, eventually we could, in principle, have AI that does the analysis and writes the papers. But do we really want to do that? I don't know.
Well, there's always like a market force. The market forces in astronomy are weak because there isn't huge financial incentive. But there are, going to be young hotshot astronomers coming up who are definitely going to do this. So I don't know. How do you feel about that? So you personally maybe don't want to do that. You want to have your finger on the pulse. But with things like, you mentioned the LSST, so the Legacy Survey of Space and Time, that's correct, on the Vera Rubin telescope. So that's going to be observing millions of transients every night. It's impossible for an astronomer or even thousands of astronomers to keep their finger on the pulse. So something is going to have to be following up on those and doing some sort of data analysis. So, for me, I don't think it is the too distant future until at least a few more of these steps are taken. I'm not saying the astronomer will be taken out entirely, but, what do you
But
think?
again, it will be just reducing the load, right? There's going to be so many triggers, but 99% of them will be just boring things, right? And it's that 1% that will be the interesting thing. So I think it will be the job of, or at least that will be the wish list of the astronomers for the AI to just filter out the junk and the boring stuff and sort of leave the exciting things for us to look at.
So we get 1,000 times more data, but we still do 48-hour work weeks because 99% of it just gets chucked because it's not that interesting, maybe.
Maybe. I don't know. From my perspective, I don't think so. The problem is the AIs are nowhere near as... The problem is they don't do logic like a human does, right? Especially the LLMs, because the large language models like ChatGPT and stuff, their whole goal is not to logically solve a problem. It is to produce text that looks like a human that's talking to you. So as soon as it's achieved that, it's very happy with itself. And it thinks, oh, I've done great. But if you've actually been an expert and you've actually used it to try and do anything worthwhile or complicated, you'll notice it's just lies. It'll spit out rubbish because the point of it is not to, again, solve the problem. It is to look like a human is talking to you. So I think the applications for AIs and stuff, like Nick said, is, I think, better. Machine learning in general and AI is, I think the application is better left in the grunt work, the filtering out the obviously incorrect data and leaving the actual interpretability and the real scientific work to the astronomer, because ultimately I don't think an AI can do this. Even if we leave it for the next few years, I don't think they would be able to reason like a human can. And in my personal opinion,
we could easily get into a whole debate here in terms of I'm
sort of
an AI accelerationist or enthusiast.
But again, I think to reduce your load on the boring things,
absolutely.
So the tedious things. I mean, we've talked about this a lot, writing reports and emails and coding. I mean, a lot of people are complaining that, ChatGPT doesn't really code properly, but I found it extremely useful, even just to reading tables, quickly plot me a graph just so I can have a quick look. In the past, that would have taken me a day or so to figure that out. Now it's like a 20-minute job, and I can either say, ooh, there's something exciting there and take it further, or just drop it and move to the next thing.
Yeah, and it's getting better every month, right? So like, it's for a lot of the stuff, it's incredible. And, as you say, then it leaves you to do the stuff you really want to do, which is great, because then we're increasing efficiency, right? So maybe you can publish papers sooner, and if it writes 80% of your paper, then also, you're right about the reports and proposals and things. That's that's the kind of work which absolutely kills me.
And it also, what's the word? Democratizes writing of papers, right?
Yes.
Some people are just very good at writing, and maybe not good scientists, but they are publishing a lot. And other people are good scientists, but not good writers. And it sort of gives those people a helping hand.
There was a paper very early on in the sort of LLM space on students. So, students whose English was not their first language, reducing the length of their PhD by like months. Because now all of a sudden they have access to good English, and they know the science, they know what they're talking about. But if it has to be presented in a certain language, which they're not not their mother tongue, that's a huge disadvantage to a student.
Yeah, but I mean, again, in those cases, AI is used as the tool to help the intelligent person make the decision, rather than the thing that does the thinking for you. I heard a really funny anecdote the other day that ChatGPT, especially, I teach younger students and stuff, and we've talked a lot to the other lecturers at UCT and stuff about the attitudes of students having shifted after ChatGPT came into view. And the anecdote goes that ChatGPT was supposed to be the bionic arm on you that is your tool that helps you really accelerate your learning and research opportunities, etc. And it has turned out to be the wheelchair that someone sits in rather than walking on their own. Because ultimately, if you use it as a crutch, if you use the AI to think for you, you're not going to do very well, because you're not learning anything at that point, right? Your neurons are not mapping the correct things that it makes memory for a person, right? So I don't know. I don't think the AIs will do everything. I'm not convinced. I think it's best left as a tool for grunt work rather than as a. It's about how you use them at the end of the day.
Yeah, and there's some students like you said, are usually using it to their advantage to really, do good work. And those are the students that are going to do well. And other students are, like you said, just using it as a crutch. And actually, that can be disastrous.
But it's very similar to when Google as a search engine became very common. Before that, everyone was, it's the end of the world. No one, no one will think anymore. They'll just Google it. And
that's
Google,
what we all do.
Yeah, exactly. But Google is a research tool. In the same way, ChatGPT is also effectively or any of the LLMs, right? Gemini, whatever, if they want to sponsor it, we can. No, I'm joking. They're all just they're tools, right? And it depends on how you use the tool. If you use the tool correctly, you get But
it's not just using the tool to produce the result that you want, but also using the tool to benefit yourself.
Yeah, to understand the result that you produce. Yeah.
Maybe, I mean, before we let you go, Nick, while we have you in the room, I know you've thought about this a lot. I've certainly thought about it a lot, but I know what I think. The sort of morals of it.
Yeah, well, can you elaborate what morals do you mean?
Well, I mean, as you lecture students, like we've talked about what it does to you sort of personally. I mean, Francois was saying, you're not learning as effectively, but then how far do you push it in terms of what students should be using and they shouldn't be using, and then researchers too. Like if they're writing papers entirely with ChatGPT and just churning them out automatically, because this is going to happen. I mean, if I think it's happening already. It's not every astronomer who is sort of as dedicated or whatever as you are. A lot of them will be looking for shortcuts.
Yeah, but I agree with Francois. Like an AI cannot really write a paper, right? It can just write the language framework that puts the science together, like that ties the stuff together. And so I tell my students, use ChatGPT to write reports, but use it as an editor, right?
Yeah.
Don't make it write the report and just copy and paste and then submit, right? You have to at least read it and make sense, see if it makes sense.
No, I agree, because like we said before, right, the LLM, these models, their point is to sound like a person that's writing or talking to you. It's supposed to write English. It's not there to think, because it can't reason like a person does. And that thinking and reasoning in the report, that's where the science comes from, right?
Yeah. And I mean, like I said, I use it a lot for writing reports and even sometimes emails. And sometimes I have to change one single word, but that one single word makes a big difference. It can often make a massive difference. Yeah.
But in terms of the efficiency, it's incredible because, you know, it's already written the email. So like, they're 80%. So, I mean, I the way I use it, and I like to think of it, is I put in 10% of the work at the beginning. So, you know, I craft my prompt carefully, and I say what I want it to say, you know, even if it's an email. So I'll just type in a few lines about what I want to say in the email. Then it can write it nicely. And then I do, so that's 80%. And then I do the 10% at the end, which is going through it and making sure it's saying exactly what I wanted it to say in the first place.
Yeah.
So that's kind of how I approach it with emails or with reports and things too.
And the same thing with papers.
Yeah.
Right?
Yeah. So, yeah, there is a sort of question of what you put into, you know, what are you putting into it? All right, Nick. Is there anything else you wanted to talk about in terms of AI? You know, I think we've sort of waxed lyrical.
We've kind of branched into just.
But I think it's a fascinating time to be working in AI, and I think that, you know, having things like the Intelligence Observatory and this virtual research assistant coming along are very exciting. Is there anything else you see going on in the field that you've seen in your travels around the world or in conferences, which you think is going to blow us away?
Oh, that's a loaded question. Yeah, I think it's the same. I guess with when Google came out and the internet came out, there are people who are just running with it and doing great stuff, but there are people who are skeptical about it. Time will tell. I don't know how it's going to pan out, but I mean, I'm enjoying it, and it is reducing my load, and I think I'm being more efficient, and so
Yeah. Awesome.
I mean, the research and stuff into ML, of course, in astronomy is now increased. You've got lots of students making that their theses. My thesis is literally on machine learning techniques. My honors thesis was on that as well. But yeah, it seems to be growing as a research field in astronomy, especially, which makes sense. I mean, no one collects more data than we do, so we end up with massive data sets that need someone to go through them.
It's an essential skill now.
Yeah, it is. It really is.
Yeah, fully agree.
All right, Nick. Thanks again for joining us. We'll check in on you in a couple of years again and see what Atlas has done, and see. Well, maybe we'll just chat to your AI.
Yeah.
Ooh, thanks, guys. Yeah, nice team.
Thanks, Nick. Cheers.
Cheers.
Bye.
So that was our interview with Nick. We tried to stay on topic for most of it, but towards the end it kind of went off the rails.
I think I got a little bit carried away.
Yeah.
No, but I mean, you know, I'm fascinated by this. As I said, like I'm an AI enthusiast, and I love what's going on. I'm trying to keep tabs on everything, and there's so much going on. But wonderful to have Nick give us his thoughts and. You know how it's looking at the coalface.
Yeah, no, I agree. It's interesting to hear, like you say, at the coalface, how these things are happening in real time, and how astronomers at least are starting to think about the AIs and how to use them in astronomy in general.
Yeah, and maybe just to dispel a little bit of the hype too.
That's true. Yeah,
like, you know, AI is being presented in a lot of fields as something which is really going to answer all of our problems and
and change everything.
But you know, from an astronomy point of view, it sounds like it's going to be a little bit slower than that. And but still, you know, increasing efficiency is increasing efficiency. So,
no, that's true. That's true. I mean, ultimately, it's a complicated field, and complicated data takes a long time to process. Just ask the astronomers who did it by hand a few years ago.
Yeah, and hopefully with things like, you know, the square kilometer array and things too, and a huge amount of data, the LSST. Maybe we will get some unknowns which will pop out of some machine learning algorithm somewhere.
Perhaps, yeah.
Which will be exciting, and then we'll all be praising AI.
Yeah.
Well, if that does happen, we'll be sure to find out who.
We definitely will.
Or at least get Nick back.
Yeah, we'll get Nick back for his 4th interview.
All right. Before we go, we should probably check in on each other. How are you doing, Francois?
I'm well, Dan. Busy, but got a lot going on at the moment. Got like 17 things I have to do all at once, but that's apparently normal for an astronomer.
Yeah.
And you, Dan?
Yeah, also, end of the year. Everything's kind of, concertina effect as everyone tries to get everything done by the end of the year.
Yeah, and the end of year events for everything that you're involved in as well.
Weekends are now full, weekdays are full, everything's kind of full. But otherwise good. Yeah.
Okay, that's good.
Looking forward to summer, so that's nice.
Yeah. We should probably talk about the elephant in the room.
There's no elephant in the room.
Yeah, there's no elephant or indeed camera in the room.
Oh, right, of course.
I like how last week we went, no, this is for nostalgia's sake that we're back in the old pendulum room, and now we're fully back as we were.
Yeah, so if you were watching on YouTube, you would have noticed by now that there is no coverage. This is an audio-only episode. The one button studio we couldn't get for today.
Book.
Very popular because it's very nice.
Popular, yeah.
And we had to grab this opportunity to chat to Nick.
Yeah,
so
it's the only time we could meet Nick. So
anyway, I don't think he missed out too much just missing out on me and Francois. So
no, I don't think so. All right, and that's it for today. Thank you very much for listening, and we hope you'll join us again on the next episode of the Cosmic Savannah.
You can visit our website, thecosmicsavannah.com, where we'll have the transcript, links, pictures, and other stuff related to today's episode.
You can also follow us on X, Facebook, and Instagram at Cosmic Savannah, and now also on TikTok. That's Savannah spelled Savannah. You can also watch the podcast on YouTube with closed captions which can be auto-translated into many different languages, including Afrikaans, isiXhosa, and isiZulu.
Special thanks today to Dr. Nick Erasmus for speaking with us. Thanks to our audio editor, Nick Rushton, our podcast manager, Francois. Thank you, Francois. Our social media manager, Sumari Hatting, assistant manager, Kaashifa Saloojee, and our other awesome interns, Sisa, Shibane, Karabo Rantutwane, Kamogelo Letsualo, Tato Nombeu, and Charmaine Mputi.
Thanks also to Mark Olnut for music production, Susie Karras for graphic design, Ryan Masomela and Mikhail Wershek for photography.
We gratefully acknowledge support from the South African National Research Foundation, the Square Kilometre Array Observatory, the South African Agency for Science and Technology Advancement, the South African Astronomical Observatory, the University of Cape Town Astronomy Department, and the One Button Studio at UCT.
You can subscribe on Apple Podcasts, Spotify, or wherever you get your podcasts, and we'd really appreciate it if you would rate us and review us, and also recommend us to a friend.
And we'll speak to you next time on the Cosmic Savannah.